All right. I would like to go ahead and provide an introduction to IxNetwork QuickTest, um, and we'll follow that with a little demo and basically explanation of the statistics that we get. So first off, the purpose of QuickTest is to automatically go through different iterations of traffic, with different frame sizes and different rates to find the best throughput for us. The other purpose of it, that's kind of like sharing the concepts with the one I just mentioned, is custom rates and custom frame size testers. So, sometimes you may know that there are specific frame sizes that you have a problem with, and you just simply want to iterate through those frame sizes using different rates to validate and make sure that there's nothing suspicious in terms of the DUT's performance behavior. So QuickTest makes that easy. Instead of having to run those manually back to back with changing the rates, restarting the test, changing the rate, restarting it again, you basically do that with one click. And the beauty of that is every time you make a change, let's say a configuration change or a software update to the DUT, you can just rerun the same configuration and compare your results historically and match it up with, say, the version of your software, and sometimes even understand where things broke. So very, very useful tool to basically do performance characterization or performance troubleshooting in routers and switches. So let's go through a sample configuration. The RFC 2544 throughput and latency test is probably the most common. And it's flexible enough that actually covers a lot of use cases, but we have actually plenty more quick tests here, 2544 being the major one for router performance and throughput testing. Now, there are two ways you can build your configuration with QuickTest. One is called new configuration. What it means is that you're starting from scratch. You configure your IPs as well as your traffic completely using QuickTest, so it automate that step for you as well. Or if you say, well, I already have built my BGP or MPLS stack, I've already configured my traffic item over those. I don't need to do that again. You would use existing configuration. So I'll go back and take a look at existing real quick in a minute to see the difference. But the core concept is the same. The configuration of the rates and frame sizes and the binary search options is the same. Simply the initial configuration part will be different between the two. So if you were to do a new configuration, um, in my example, I only have two ports that we're going to do a bidirectional test with IPv4. Things becomes pretty simple. You specify the ports you're going to use. If you had more than two ports, actually, you could have many-to-many or fully meshed source destination port mapping, which is pretty helpful, especially if you want to test your backplane and stress your DUT pretty well. This, basically with two clicks, you could create a 128 fully meshed tests port mapping. So it makes that very easy as well. So next, we will look at the MAC address and IP. Automatic is actually the way to go if you have a lot of ports. Basically increments the IPs based on a pattern. Or if you think that the IP increments are not contiguous or predictable uh, because of whatever reason, if you have because of your connectivities or your system under tests the way it's designed, then you wouldn't use a manual. Next, we'll go ahead and look at layer 4 settings. Since this traffic is also being built by QuickTest, it lets you pick a header, TCP, UDP, or none. You could insert IP priority bit in there, and also the payload settings. The payload also can be very helpful. Sometimes you decide if you want to basically go through different traffic patterns to understand if the chip is dropping on different patterns. You could do that. you would have to create different quick test configurations basically and run them in different times to be able to actually make that comparison. The same configuration will not iterate through these settings you see in the screen. So we'll go next. We're done with that. I'm sorry, I pressed back instead of next. Okay, so next we look at the frame size. It's where we are configuring frame size increments or iterations that basically changes the frame size here. You could say increment. The increment is very helpful if you do a full frame size sweep. Let's say you start from 64, you go all the way to whatever you like. Um, for purpose of the demo, I just basically did two 512 and 1518 frame sizes. This is also by default what you're looking at, somehow what you would call an iMix. So a loosely representative of what sort of frame sizes you see out on a wire. Anyways, you could come up with your own list and punch it in as you wish. Next, we'll configure the stats. This is saying basically what extra stats you want to see. Again, this test is built around latency. I'm sorry, built around throughput, so that won't change. You always have throughput numbers. But you know what? If you wanted to look at latency as well, great. It will show you. It will not make any decision based on throughput, based on latency, but it will also show you right next to the throughput numbers. Useful in a lot of times and for troubleshooting purposes specifically. Next, very important, your rate settings. So first thing is, how long do you want to run each iteration before you make a decision, especially in the case of a binary search? What that means is that I'm going to send the traffic for 20 seconds, and then I'm going to collect the statistics and look at the numbers. And if there is no frame loss, for example, which is defined by the threshold down here, then I'd say that's a successful iteration. Now, based on success or fail, the binary search would adjust up or down. So a lot of times you say, well, 20 seconds might not be really enough. Let's do 2 minutes. Some people may say, well, you really don't have an application that cares about a packet loss in 2 minutes, so let's just stick with 20 seconds. These are going to be defined by your test objectives. For my own purpose of demo here, I did only custom. So I said, you know what, for each frame size, just do 1, 10, 50, and give me the results. So the format of the results, the way it comes out, is pretty much the same, so it doesn't matter for me. Binary search does take a long time, so I skipped that. With binary search, however, one thing that we have, gives you extreme flexibility. Actually, these are some features that we recently put in the product. You can change the logic a little bit. You could control the flow. You could say, you know what, if I feel like my DUT is a very high performing DUT, there is no reason to start at 10% frame size. Let's start at 60%, and especially if you're running a frame size sweep test, which takes hours and hours. Anyways, once that's done, we click finish. We have the configuration. Configuration is going to look something like this, and we'll start it. So like I promised in the beginning, I'm going to go back and show you how we build it if we had an existing traffic or configuration. So we'll click on existing configuration mode. And as you can see, the number of items is reduced because then there's no conversation about how to build the traffic and stuff like that, IPs and whatever. It's going to basically work. It's going to work like you already have those configured. So you just basically pick the traffic item you want. It allows you to actually have a background traffic. The background traffic is going to be basically pumped out. We're not going to change the rate on the background traffic. It's going to be passive traffic. If you just want to have back pressure on the duty to just basically understand how the duty behaves when there's that background traffic, you could do that. Otherwise, what you put in the included column, when you check that, that will be the traffic you would use for the binary search and all the other cool stuff. Rest of the parameters are pretty much the same. Again, those are the core parts of the quick test, will not change. Now, since I've already ran this test, let's take a quick look at the results and see what we got. One thing to also point out is every time you run a test, the results are saved in the data miner. It's a folder that's actually on your local machine. They're saved in the CSV format. You could actually go there using this open result file location button. You could go there, you open it up, you could open up the CSV file in Excel and do all sorts of cool manipulations on it. If you want to do some calculations, you want to do charts, have at it. So otherwise, if you just want to look at the numbers real quick, we do have this view here that would help you out. Timestamps, obviously, test names, everything here. So if I click on aggregated results, what's going to show me is that it's per iteration. So if you had 100 ports under the results section, you're going to see 100 lines in each direction for each frame size. But under the aggregate results, it will aggregate all of that per frame size, per iteration actually. So really depend on how you would like to look at it. But real quick, if we, for example, look at that first iteration, frame size was 512 and traffic rate was 1% as I configured. Frame loss was nothing, so pretty good. I have no loss in any of my tests, kind of expected because I have what you would consider a back-to-back configuration in my virtual setup. Latency numbers not that great because it's a software-based solution and not much time sync going on. But if you had hardware running, you would get really nice and accurate latency numbers as well, represented in each iteration. Anyways, that was a quick demonstration of IX Network QuickTest, its capabilities and purposes. I hope that it was helpful and thank you for watching.